Hi everybody, this is Mr. Murphy. I just wanted to do a quick lesson for you guys regarding negatives under our radicals, as well as just establishing our domain with radical equations. So I know this is something that Mr. McGivney's videos dealt with a little bit, but I just wanted to have it all in one place for you guys, go over it quickly, and just to hopefully shore up any questions that you might have. So our first problem here, we're talking about square root of negative 64, right? If we're taking the square root of a negative, we know that that does not exist, right? There's no two numbers that are going to multiply back to get you to a negative number. I know that maybe a couple of classes, I think Mr. Dewey may have touched on imaginary numbers, but for most of us, we haven't gotten into the imaginary numbers yet. That's something that next chapter we're going to be dealing with. All right, so square roots of negatives, we know that that's not going to work. Does not exist. Imaginary numbers. For our second problem here, we're talking about the cube root of negative 64. So if we're trying to solve this, we're saying what three numbers multiplied to the same, what number multiplied the same three times is going to get back to a negative. That's possible. It's just a negative number. So to solve this, we want to write this with as small base as possible. So this is like saying we've got in our parentheses, this would be negative 4 to the third. That gets us to our negative 64. And then if I rewrite that cube root as just to the 1/3, right? That 3 and 1/3, they're going to cancel each other out, and we're going to be left with just negative 4 for this. So basically, the bottom line with this stuff is we're talking about even roots versus odd roots. So anything that's an even root, like number 3, we see square root of negative 16, does not exist, right? When we're talking about fourth root, even root, so this is a does not exist as well. Cube root, that works. So anything that's odd will work. So negative 729, whether you have your tables out from the start of the chapter or not, I know that this is the same as negative 9 to the third. Then I want to raise that to the 1/3 to simplify it. So this just equals negative 9. Sixth root, negative number within the radical. Without doing any work, we can just say that that does not exist. So all you're looking for on these is even root versus odd root. Odd roots of a negative, you should be able to simplify. Even roots of a negative does not exist for the moment until we get into our imaginary numbers. All right, establishing domain in radical equations. So this is kind of what you saw in the previous lesson from Mr. McGivney. But basically the rule is what? We can't have, as we just said, a negative underneath the radical, but then we also need to pay particular attention to when we have a radical in our denominator. So with these, if I kind of just take this as 3 individual parts. So when I'm looking at establishing a domain for that first part, I'm saying that 5x has to be greater than or equal to 0. So if I simplify this out, divided by 5, we get x is greater than or equal to 0. With our middle term, we've got 2x minus 1 has to be greater than or equal to 0. So if we solve this, right, that's going to simplify to x greater than or equal to 1/2. And then with our last one, this is where we need to be a little bit careful, because not only does it have to be greater than or equal to 0, if it equals 0, now we have 0 in our denominator, which we know would be undefined. So on this particular one, we have to say 3x minus 2 is just greater than 0. So I'm just going to star that because it's a little bit more that we need to pay attention to. So we get 3x is greater than 2. So we get x is greater than 2/3. So now if we wanted to figure out what our actual domain is here, if we write this in interval notation, it needs to be an overlap of all 3 parts, right? So this one's not too bad. I think we could see what it would be. This would just be from 2/3 to infinity. It's saying greater than 2/3, so we're going to want to use parentheses for that. And obviously with our infinity, we're using a parenthesis as well. If you struggle with figuring out where the overlap with this are, it sometimes helps if you just draw a quick number line. This one, like I said, hopefully kind of visually not too bad, but if you wanted to draw a little number line, sometimes I've found that helps as well. So if we draw each of these individually, right, what we're looking for in this is where the overlap occurs. So where's the overlap in all this? Where all 3 parts are is right there. Where this is helpful is if you have them going in different directions, you know, one's greater than, one's less than, then it might be useful to use your number line to help you solve it. All right, let's quickly look at number 2. And like I said, we're not actually going to solve these. We're just going to look at what the actual domain on these would be. So with this one, number 2, that first term, we've got a negative in our radical. So we're going to say negative x plus 7 has to be greater than 0, not greater than or equal to. So we solve this out. I'm just going to bring the x to the other side. So we got 7 greater than x, or the way we'd write that, x is less than 7, right? With our next term, 5x minus 1, it's not in, or it's not underneath the radical, or it is underneath the radical, it's not in the denominator, excuse me. So we want to say greater than or equal to 0 for this one. We solve this out, we're going to get x greater than or equal to 1/5. And then our last one here, think about what we just did up top. We said if we were dealing with cube roots, it could be positive or negative, right? So we got no restrictions for a cube root. And that would go for any odd root. So cube root, fifth root, seventh root, anything like that. There's not going to be a restriction. It could be a positive number. It could be a negative number. It could be 0. The only thing you'd have to worry about on that stuff would be if it were in the denominator, you'd say that it cannot equal 0. So with this one, to establish our domain, we've got greater than or equal to 1/5. So we need a bracket for that. And then less than 7. So we've got a parenthesis for that. And that would be our domain. So then if you were to solve these out, obviously what you're looking for when you're actually solving them is to make sure that your solution would be within that domain that you just established right there. So this should always be kind of your first step when you're setting up with your radical equations. Hopefully that helps. And then I'm going to also post a video of a little bit of a review of just the entire chapter, kind of going through each type of question. So hopefully that will be helpful as well.